We're back, and this is unit 2.3, and what we're going to be focusing on is calling a void non-static method. We already did this, but I'm going to do it again. And to do just that, we'll jump right into example 2. And example 2 says change the point P1 back to 0, 0, and change the point P2 to 3, 4. So to do that, we're going to call the set location like we did before. So I'm going to do that, P1 dot set your location, and if you look carefully you'll find that set location comes up, and if you look at set location in my API here, it has 1, 2, 3, 4 of them, and this is called overloaded. Okay, because what happens here is we can set location by giving it a point, we can set location by giving it a point 2D, a different object type, and then we could set location by giving it the x and the y values as doubles. We could set location by giving the x and y value as integers. So these 4 methods here are called overloaded because there are 4 ways to set location. An overloaded method is a method with the same name, but different parameters here, different parameters. They're all void. See, nothing is being returned. Okay, it performs the action, the behavior of setting the location, but doesn't send back anything. So I'm going to say P1 is going to go back to 0, 0, and P2, I'm going to set the location. You could always use this nice code completion stuff here, 3, 4. All right, and that's simply calling a non-static void method. No, non-static because I didn't say point dot set location. I used the actual object, the actual instance of a class, a different instance. Remember, a specific instance. This specific instance went to 0, 0. This specific instance is 3, 4. They're both points, but they're different points. Now, this is calling a void non-static method. Nothing comes back. So let's say I try to say, okay, point K, it's going to throw an error. It's going to say, hey, this don't have a return. It's void. You can't assign that to something. If a method has a return type, we could assign it to something. So I also added that. This is not necessarily part of this section, but I'm going to go ahead and find the distance between these 2 points. And if you remember, the distance formula is the square root of the difference between the x coordinate squared plus the difference between the y coordinates squared, and I'm going to do that using the math class. So it's going to return a double, so I'm going to go ahead and say double distance is equal to, so math dot square root, and inside here I need to put the squares for math.pow, that's for the difference between the x's, and then plus math.pow again. Now I'm doing this by using the code completion, so then I could just fill the pieces in. This piece here needs to be the difference between the x values for P2 and P1. So I'm going to say P2 dot get x minus P1 dot get x, and the b is what the exponent squared. A, again, let me drop this down so we could see. Right here, I'm going to do P2 dot get y this time minus P1 dot get y, and of course that's also being squared. So what I just did is I used the distance formula using all of the math class. Math, these are static calls. These are static calls. I'm calling math.square root, not the instance of the class doing it, but the class itself. Math.pow, math. These are non-static calls. But here's the difference between these. These calls return something. So this guy is going to return the value for the x coordinate, for P2, and same here for P1, and so on. And then the whole math.pow returns a value as well. So this is a lot of stuff here being returned, and then eventually the square root gets returned, and I store it as distance. It's a double. Then I'm going to print it. print ln, and I'll print distance. So I just found the distance and I printed it. Now, that's how you call a method. You're simply either using the object to call it or the class. When you use the object, it's a non-static call. When you use the class, it's a static call. The other thing that we want to touch on is a null pointer. If you create an object or instance of a class like this, and you do not specify by saying new point, if you don't do this, okay, then you're not actually creating an instance. The word null, the keyword null, could be used in place of creating the point, instantiating, which we did further back here, up here. So if we don't instantiate, you could use null in place of it. But this is called a null reference. Why would we want to do that? Well, we want to do that if we don't know what point this is going to be. If this program is going to run, or code is going to run, and this point is going to be something in the future, but we don't know what it is currently. But we want to have it so that when we get the point down the road, we can assign it. Well, we start off with it being null. There's one little error here though. At this point, even though the code doesn't show an error, this would be an error. It's called a null pointer exception because you cannot ask the instance that was not actually created yet to actually perform one of its behaviors. You can't say, hey, do something, because null means you're not in existence yet. So I can't say to something that's not in existence to actually do a behavior. That would be the same as a person has not been born as yet and we're asking them to jump. See, it doesn't make any sense. You have to be in existence for you to perform any of your behavior. So I'm going to run this, and we're going to see the distance, and we're going to see the null pointers. Let me run that. So here, these are all the stuff that came from before, and we have our null pointer as we expected. The distance is 5.0, like I said to you, because I made a 3, 4, 5 triangle in case you didn't realize. One side was 4 and one was 3 from the 0, 0, so 3, 4, 5 triangle. And then we have a null pointer here. So that's something that you want to keep in mind. If an instance was not created yet, don't actually ask it to do stuff. So I'm going to put a little comment out here. Now, the next thing we want to jump right into is to build a simple class. Okay, this is a little bit ahead of 2.3, but it's fine. We should jump right in and do that. Now, we're going to build this class called quadratic solver, which is going to solve a quadratic equation. Now, we're going to make it so that you can only solve quadratics that are real answers. Okay, imaginary ones are not going to work. So, as I said, simple class. So, to do that, I need my project explorer. If you look on the left side, you'll see I have my code enumerated here with all my numbers, but I don't have my Explorer window, like the one that has all my projects, right? How do you do that? Some people don't know how to do that, so let me just review that. You go to Window and Show View. See, this is all the views here. See the console? I could bring it up, I could get rid of it. This is the Package Explorer. If I click on this, it'll show up on the left, right over here. So now that I have my Package Explorer, I'm going to find the project that I want, which is the computer science. And I'm going to expand a little, expand a little. I need to know where I'm doing this. So I'm going into Unit 2. That's where I want to actually make my quadratic solver. So I'm going to create a class. And the class I'm going to create is called quadratic solver. Quadratic solver. All right, no main method is needed because we already have one. So I'm just going to hit Finish. And here's my quadratic solver. It's in Unit 2. Now I want to make sure this package up here, that's what it's saying. It's saying your code is properly organized in different folders. This is inside the Unit 2. So now I'm going to go ahead now and make my quadratic solver. First, I need attributes. What do you need to create a quadratic solver? Well, I need private double. Attributes are going to be attributes, instance variables, I'll put a slash here, or instance variables, same thing. Private double A, B, C. Realize I did A, B, C, but they're not assigned anything. Okay? They're not assigned anything yet. Then I'm going to make my constructor. And to make the constructor is just the same name as the class. So quadratic solver. I'm going to make two constructors. I'm going to make a default. And I'm going to make another one that's non-default. So I'm going to go ahead and make another one that's non-default. The one that's non-default, I'm going to put in the variables that I want. You have to tell me these three things if you're going to make quadratic solver. So now, in the default constructor, I'm going to make all these things 0. And if you're wondering why did you write 0.0, because they're doubles. I could have put 0 and then the widening would have happened for me, but I'm going to go ahead now and set these up. So you got to go this dot A is A. For those of you who was in intro, this should look very straightforward. Alright, I can't just say A equals A. Let me just show you one of the famous mistakes. This shows up a lot on AP Computer Science exams. You can't do that. You see this yellow line here? It's saying you're setting the dummy variable to the dummy variable. You're not doing anything. What you want to do is you want to set the dummy, as called pass by value, to these. Now, something strange about this here. Attributes, even though they're not assigned anything, gets an assignment called a default value. Default assignment. Unlike the local variables, if I were to just go and print these, they would print their default values. So now the default values for numbers, 0. The default value for objects is null. See, I had to show you, this way I'm showing you these pieces because they all tie in. The default value for objects is null. So remember that P6, so if you did private point P6, even though you didn't set anything to it, it's automatically null. So if I go and say P6 dot set location, it will throw a null pointer. If I go and do work with these ABC right now without giving them any value, they're all 0. So that's the difference between this instance variable and a local one. Now if I go ahead now, and this is called overloading constructors. Because I have two of them. But you should remember the point was the same way, right? Point had a no parameters in here, and it was the point 0, 0. And then it had one with two x and a y. And that was a non-default, so that was an overloaded constructor for point. Very common. Then we're going to keep moving on, and we're going to make another. So here comes the behavior now. Need some methods. Behaviors need some methods, okay? The first thing that you need when you're doing quadratics is a discriminant. So to find the discriminant, now you realize that this has a little error here. It's because we need to return a double. So I'm going to go ahead now and do a discriminant. Discriminant is b squared minus 4ac. So I'm going to return math.pow b squared minus 4 times a times c. That's my discriminant. Well, the discriminant is important because you want to necessarily solve this, okay? We need to solve this, so I'm going to write another method to solve. I'm going to send back a string. It's going to be solve because I want to solve the quadratic. So to do that, I need to have two values, right? So I need string x1, and that one is going to be, you got to remember how it works. There's a numerator and a denominator of 2a. This is the quadratic formula. So it's minus b plus, now I got to do the square root of the discriminant. Math.sqrt discriminant. Okay, so math.sqrt discriminant is what I want to figure out the discriminant and then take the square root of it. So you will say, well, where did this come from? Well, this came from here. We just wrote that method. So I'm using it inside of the math to get the square root and then plus. All right, at this point you may be thinking, what? We have an error there and you didn't even touch that error. And that's all right. This is the minus version. So right now I purposely want, so let me just return x1 plus a space plus x2. All right, so what I have here right now is type, a type issue. This is a double. I can't assign it to a string. I can't do that. That's what we said before. So I need to turn this into a string. You may think, oh, just do that. Just cast it. Wrong. See, what I said is you can't just decide to turn things into one from one type to another just by casting. I'm going to suggest try it and see if it works, okay? If you're playing around, try it. All right, the way to do this is to say string dot value of. Okay? And what I did there is I wrapped that inside the string dot value of, and it turns it. That's a static call. Make sure you let this stuff sink in here. That's a static call. I'm doing a bunch of static calls. I also did a non-static call here. So what happens? You keep saying you need to put the class dot the method or the object dot the method. How come discriminant's just here by itself? Well, it's not ever by itself. Whenever you're inside the same class and you're calling a method, when you yourself is doing it, me, when I'm speaking of a reference to myself, the word is this. Even though you don't write it, it puts it there for you. So this, there's always a dot before a method, always. So even if you don't have one, this is there because it's a self-reference. So I'm going to do the same thing down here. And of course, now I solve. All right, so of course, I want to overload this. I want to overload solve. I want to make another solve. Public string solve again. This time I'm going to take in the A, B, and C. Taking the A, B, and C, and then I want to solve. Well, let's be technical here. This dot A is A. This dot B is B. Here goes the this again. This dot C is C. And then I can say return solve. What? How does that work? Well, I'm going to say this dot solve. See what I did? I got these three, update the instance variables, the attributes, call the method that I called before. Okay. This is the name of this is called a helper method. You see, this guy helps this guy. And a helper method is procedural abstraction. I could literally make this private, so you can't call it outside of the class. And because I can't call it out of this class, this would be perfect. This is called hiding the information underneath the hood. I'm going to leave it public. It's still procedural abstraction. Is that this method does not care about how the implementation of this method is. All they care about is that it works. And we do that a lot. See, math.square root, we don't really actually know how the square root is calculated. We just know it works and we use it. That's called procedural abstraction. So I overloaded solve. We have two solve. We have two constructors overloaded. Same name. Okay, same name, solve. Now I could actually create one more method, and I'm going to make it a void, and I'm going to call it print solution. And so print solution is going to return solve, and right there we have a big error. Return solve. Ooh, big error. Yes, obviously. Print is void. No return type. So I can't return solve. You could return nothing. A void is nothing. Okay? Let's make sure we get these little things on the wraps here. So generally when you see void, you don't want to return. So chances are you're going to be printing. And so yes, I could print the solve. And it's not just solve, it's this dot solve. Now, you could write it like that, or we could print the solution again. In this one, we could overload it. And if you're wondering, why are you overloading everything? Because you're giving the person flexibility. See, this is making your code very flexible. And if I return, so right there now, I could do solve A, B, C. So you see, I'm writing my methods, and the methods are helping one another, right? Like the method before, this guy helped the other guy, and in the method, they keep helping each other. That's the way you want to be thinking about writing your code. Okay, so make a little note here. Overloaded print. Okay, I'm driving this point home because you want to think like that. When you overload, same name, different parameter list, sometimes no parameter, maybe 1, maybe 2, maybe 3, but giving the person flexibility. So what's the flexibility here? You could print the solution. If you created a quadratic solver, you could print the solution without telling it A, B, and C. Or you print the solution by telling it A, B, and C. It all depends on your constructor. If you've constructed one with A, B, and C already, then you could print the solution this way. If you've constructed it with A, B, and C, you could print the solution this way as well. You could say, here's the A, B, and C again, even though you already gave that information. So, quick wrap up. This is creating a simple class, but there are a couple of things that I wanted to drive home that are a little bit further down in the course, but it's good to see it so that when we do it again, it becomes repetition. When you have an instance variable, okay, like if I were to print, I know it looks kind of weird here. If I print A, this would print 0.0. This is not like a local variable. Like if I had int x and I don't assign it anything, I'll show you the difference here. See, if I do print x, you're going to get an error. I showed this before, but I have to keep doing this so it becomes repetitive. Local variable not initialized. Well, how come it didn't say this one not initialized? Because it's an attribute, because it's an instance variable, it gets a value whether you assign one or not. What's the value? A default value. Numbers, 0. An object, null. Boolean, false. If I had a Boolean up here, automatically false. I don't have to set anything. Okay? So those are the things that we want to pay attention to. I want to pay attention to overloaded. We'll be seeing this a lot more. And I want to pay attention to helpers, right? If you've created something already, you want to use what you've created to create a new thing. Okay, you ought to always think like that. Makes your code simple, easy, straightforward. One last thing before we are done. Precondition. So what's a precondition? This solves only for real values. Okay, so if the quadratic that you made is going to give us imaginary, this is going to throw an error. Okay, it's going to throw a NaN error, not a number, NaN. If you've ever seen that and wonder what it means, not a number. That there is going to throw. So that's once you say what your code's going to do, it's perfectly safe to have errors as long as you explain them in your code. So saying a precondition is important. Only put in stuff that have real values, and this thing would solve them. Now, what we're going to do here is for the some parts of Unit 2, we'll come back and use this quadratic solver to kind of look at all the different points, all the different concepts that we want to study. We're going to be using this. We're going to be seeing how the overloading works and how the different construction works and all that stuff. So we're going to keep this and the remaining part of Unit 2 here, and we're going to pick it up right here with 2.4. This is the end of Section 2.